Dear friends, we come right now to the third session of our SMPS design. Basically, here is what we got to design during our last two sessions. A full bridge rectifier and taking part into a half bridge topology circuit. So for this, before we proceed, we are going to put in place an oscilloscope. This will permit us to see the variation. Okay, now what we are going to do basically in this part 3, we will be switching the MOSFET with the help of ATmega. Like I said already, these pulse generators are generic components which you can find them as components in real life implementation. So let's get to take on Arduino Uno. Now, on Arduino Uno, we are able to generate a PWM signal of a PWM signal switching at the frequency of 100 kHz. Now, if we zoom, we are going to see here together. Arduino basically has 3 timers. We have timer 0, timer 1, and timer 2. It can mostly be seen here. Yeah, OC2, OC1, and OC0. Yeah, those are the different timers. Now, for the sake of our simulation, we are going to make use of timer 1. Timer 1 here actually consists of pin 9 and pin 10. Okay, we just get to carry our pin 9 and pin 10 and we plug it directly to our MOSFET input, because the Arduino code we are going to write will generate the PWM code for switching this MOSFET at once. But now this PWM we have a peak value of 5 volt, and that will be a constraint because the two MOSFET will be switching at their full potential. So let's get to simulate and we see the result. Okay, there is an error. We have not uploaded the code. So let's get to see what the code resembles as. Here is what the code resembles as for anyone who wants to maybe get it. Here it is. What the code is simply saying, we are setting pin 9 and 10 as output, and here is the line of the code that permits us to generate complementary PWM signals at timer 1 of our ATmega. Now, at this level, we are setting the duty cycle of our PWM wave. Like we said, we make sure the dead time of our MOSFET are being respected. There should not be any situation of where both MOSFET are actually being on. So let's hope you guys know already about this export compile program. If you don't know about it, look for one of my videos in my channel. Once you have export compile program, you get to click on Arduino. You go to the location maybe where you save the work. Document, test 1, switch MOSFET, build. Okay, here it is. Then from there we see, okay, so now we can simulate and we will have our PWM. But before that, let's connect our oscilloscope so that we are going to see the result together. Okay, so that is it. Our Arduino is switching at a very high frequency of 100 kHz. It took some time for the oscilloscope to actually map output here. The once that is done, let's get to 7032. Okay. You guys see what's happening here. We have which one is this? Okay, the yellow is for the lower MOSFET, the blue is for the upper MOSFET. So if you get to see, once this one is on, it goes off, but it takes a little bit of a very short period of time before the next one comes on. That's actually to respect the dead time of the MOSFET, and that's the complementary switching. There is no situation where both of them are on. If any situation occurs as that will be a damage to the circuit and everything will just get boom. Now let's look at the result in our system. Now we mentioned that the MOSFET are not switching at their full potential. If you get to see the output at in our circuit is increasing very slow compared to what we saw in our preceding videos. So if actually this is your first video you're watching from my channel, make sure to subscribe and watch the first two editions which we had to carry out. So this slow increase in voltage is due to the fact that the MOSFET, they don't fully turn on, fully turn off, but they are just doing stuff partially due to the just 5 volt Arduino provide. Okay, now how do we resolve this issue? We simply resolve this by using a gate drive controller. A gate drive controller comes here basically to provide the necessary voltage able to switch our MOSFET. And as we mentioned already, upper MOSFET, its source is not connected to the ground, so the VGS, which has to be greater than the threshold, will need a special kind of input. So for the drive controller, using the L6384, whatever I take, hope you can see the difference. We have a through hole and a surface mounted in the PCB. From there you see, okay. Now we place this component here. Now at the level of this input, you simply send the input PWM. We are just going to send that off pin 10. It won't be necessary to send the other one since this controller is part of its job to generate it out of it. Now to supply, we supply with DC. The necessary DC actually requires to play on the gate voltage of the MOSFET. Let's say here we are going to put anything within 10 to 15 volt. Okay. And we get to set our ground. Okay. Once we set our ground, this V out here actually takes in as value the source voltage that is at the upper MOSFET. So we are going to connect this over here. Once that is connected, now if you notice we have HVG and LVG. Okay, HVG is actually for the upper side MOSFET, so let's connect it from here to here directly. Yeah, we're going to see the result there on our oscilloscope. Now for the LVG, we connect it from here to the lower side MOSFET. We see the difference. The higher side MOSFET is the one in which the source is not related to the ground, and the lower side is the one in which the source is related to the ground. Okay, now for this DT and SD, we are going to simply connect it through a 10 kilo ohm resistor, then taking it down to the ground. So to take 10 kilo ohm resistor, we look for a resistor. Okay. This and we place this there. It's basically already 10 kilo ohm. Then this one has to go down to the ground. Okay, now for this V-boot, we are going to connect a capacitor over there. Capacitor here right now will be to relate the V-boot and the V-out voltage, as we have been seeing maybe from here. There it is V-boot and goes out to V-out. So we are going to use a capacitor of 100 nanofarad. Let's rotate this. And place this in here. Okay, it stood pretty well. Hope you guys will be able to get it from there. And okay, now let's set the value to let's set the value 100 nanofarad. 100 nanofarad. Then we see, so generally that is it. We have simulated with 8 MHz just now. Now we are putting in place a gate drive controller, the L6384. Okay, let's get to simulate this right now. Okay, as you can see the result right now. I don't know if you notice how really quick our voltage span right up to 25 volt, while initially when it was just with the at mega, it was delaying right from 20 before we had to increase to that level. Let's get to simulate it back and see the output. Okay, it went at once to 25.2. So you really see that the MOSFET here, they actually be fully switched on and off. Now let's interpret the oscilloscope reading. Okay, obviously for the upper side MOSFET, switch it, we need a different peak voltage, and for the lower side MOSFET, we need a different peak voltage. Those are the various results we do obtain. The main objective here of this L6384 is to fully switch our MOSFET. Hope you will enjoy the video, and if anything is not really gotten, you might comment in the comment section and I'm going to respond. And if this is the first video you're watching, I will advise you get to watch the first 2 editions. Okay, now let's proceed into connecting now the load and see the behavior of our system. For the load, let's take a motor. We've obtained 25 volt at our output, so this 25 volt should obviously be able to which has such voltage rating. Maybe DC motor actually. Okay, let's check out the ratings. 12 volt, yeah, everything pretty good. I love that. Okay, now here is what we are going to be seeing in our next video, that is the 4th edition. As you can notice, the motor is not rotating at all and the voltage has dropped drastically to 0.13 volt. So in our next video, we are going to be using Arduino microcontroller to regulate the voltage output as you connect a load. So hoping to see you guys. Make sure to subscribe, like the video. Anything not understood, comment at the comment section. See you guys.